Alright, I'm gonna continue playing Turing Complete today. And I think I'll do it for 2 hours. Depending on how difficult the challenges are and how exhausted I get from the challenges. So, and I think the order here doesn't matter. I'm gonna start with this one. Our education system traditionally teach by tricking students into doing the wrong thing and then teasing them. I'm not sure it benefits the students, but teachers love it. Create a circular dependency. This is a circuit where the input of a component relies on its own output. In a circular dependency situation, it is not possible to determine the output of a component, because you would first need to determine the input, which relies on the output, and so on, hence the circular. This state is normally not allowed in other levels, but in this level, the goal is to create it, so you understand what it is before going forward. Make a circuit where the input of a component depends on its own output. So I'm not sure. Oh, there's sound now. So where's the output and the input? Don't understand this. Instructions are not very clear. That's the issue. Create a circular dependence involving at least 2 components. Yeah, okay. So apparently, yeah, that was super easy. And the other tests already alerted me to that. Using a maximum of 3 components output on only when an odd number of inputs are on. Damn, this is gonna be hard, I think. Maximum of 3 components output on only when an odd number of inputs are on. This level has a hint. You can use it if you get stuck. Yeah, this is gonna be hard as fuck. So I need to use 3 components, I think. Yeah, so let's see. Doesn't increase here. Yeah, so now 3 of 3. So I can only use this 3, and I need to pass a bunch of tests. But this already fails. I go back 1%. So yeah, but now I can use more than, there's 1 input left. So I can connect 2 of them into 1 gate. So how am I going to do this? So this one is on, that should be off. So obviously I can put this, it's gonna turn it on. And I can put in this because it's gonna turn it on. Let me check to see if I'm right. Yeah. Oh, it passes. Oh, so the desired output should be on. So this is correct. But now it should be off here. Oh, that should be on. Okay, so this passes the first three. Probably gonna fail here. And there's too many tasks, that's the problem. I'm gonna get confused in the middle of it. Hey, Edison. You're the one that recommended me the. Forgot what it was. Oh yeah, the C++ channel, right? I forgot the name of the guy.
Hey guys, Chili here.
This one, Chili. Yeah, thank you for recommending me that. I've watched the beginner series, and I'm on the intermediate one, and they're extremely good. I'm probably gonna watch them a lot more times, obviously, because I'm not doing the things that he's telling me to do. But Java, true, yeah. But I don't think I'm gonna learn Java. It's just too many things. It's too many things to learn. Make game, yes. I think C++ is probably the language that I would end up uh, studying the most. But I'm not even sure about that because there's too many things to do in Python still. Roblox hacks in C++, don't. Nice. I don't even know. Roblox is a game, right? But I don't know how it works. I've heard a lot about it, but mm, nah, man. I have to do this stuff. Yeah, I've been looking at too many things, then I lose focus. I have to focus on what I'm doing. Uh, Otherwise, I'm not gonna advance on what I wanna do. So I have to think about how I'm gonna get this stuff correct here. So if I'm not mistaken, yeah. Thing is, I can only use 3 inputs here. So which ones are probably gonna be better? This is a lot more difficult than the previous ones. Yeah, the AND gate's obviously gonna work for the first one, but then it's gonna fail for these ones. So it's probably not that. And this already fails. Oh, I have to get it the specific input the correct way. So this passes this and fails this. So I can connect this one here. Yeah, now it works and fails on this one. So when both of them are on, then it should be off. So how can I achieve this? If I go through here, it's not gonna work. because the other ones are still activated. I'm not even sure what's the best way to think about which ones to select. I'm having trouble with this. Which ones are gonna be more likely to have the best combination to pass all the tests? They say they have a hint as well, so I might have to look at that at some point. So let me think. How can I make this off? While make passing the other tests. Can only use three inputs as well. Maybe I should start by trying to pass as many tests as possible with only one input and go from there. Yeah, so the first is an OR gate. But then when both of them are on, it needs to be off. Which is an XOR gate. So let me think. Because this is probably gonna fail. Oh no, this works, I guess, for the first test. Pass, pass, pass. So it is an XOR gate on the first one. Then the other input has to be on if one of them are on. And wow, that's weird. Has to be on and off at the same time. And put the OR gate here and see what happens. I want to put this here. So now it's failing on this one. Both of these are on, that should be off. So maybe I can connect this to the other one. Or I can make a NOT gate there. Yeah, but then I'm not sure if the XOR is gonna work here. Yeah, because it turns it on when only one of them is on. So I need to make sure, I need to make it so that the XOR turns off somehow on this one. So it has to do with the third input, obviously. Let me change this to another gate and see if what happens. Yeah, but I need one that is gonna turn it off. Yeah, it has to act like an OR gate in the first. It's the third input. Let me see how many this passes. So it fails on this one. And this one, it's well, how does this? Let me see. I wish they had numbers here, so it is so it would be easier to see which one I'm at. Oh, so it doesn't act like an OR gate. Only on the first one, but then it fails on the second one. So I need one that tutor. What do you mean? it's it's hard, isn't it? At first, some of the previous challenges I thought it was impossible to do it, but eventually it works. It's pretty much a game that you put logic gates together and eventually you build a computer. I think at the end you build a computer, your own computer. So it starts at the ground zero, and then you start adding components, and eventually it gets more and more complex, and then you're able to build your own computer. But it's extremely difficult. This is already past the basic level. Let me see if I can show you. So these are the initial phases where you build the AND gate, the OR gate, XOR, and so on. And now starts to get really difficult, apparently. Yeah, learn building up C. In this one, you can only use 3 inputs, and you have to pass all these truth tables here, these values. Yes. So this one passes these first ones, but then it fails here when the third input. I don't understand what do you mean. Build you a PC? So it has to be off only on 2 of them and on the other ones. I think I have to use the other gate to achieve this as well. Because there is no input that is gonna achieve this. For you, and when you build PC, it's different. It's not the whole PC, obviously. It's just the configuration of the logic gates. To build the whole PC, you're gonna need money and a bunch of companies to build the chips for you. Yeah, maybe this one can work. No, it doesn't. Because it has to turn on with only one input. So I can make it an area here. The area is gonna pass the first one, and it's gonna fail this one. Oh, but this one relies on this one as well. That's the problem. Yeah, it's building up the components. Think of it like, imagine if there was the input on the chip, and then you have to. It's like teaching you how the computer is designed. Let's say in the hardware level, which is pretty much these logic gates and the connection on wires. And you can see that it shows here the current flowing. And it's not a perfect game, but so far it has been helping me to understand better how it works. No, it's impossible, I think. Speedrun this? I spent 1 hour just in one challenge yesterday, the XR gate. Alarm? This alarm you're talking about? Maybe one day, but I don't know. It seems like it would be impossible. I don't know if other people have done it. I've only seen I've only seen a couple of videos of people doing this. But they are definitely not speedrunning. They weren't speedrunning. This alarm here is just so I can count the amount of time I'm gonna be streaming. Because I have other stuff to do off stream. So I can't be here for. I think I'm gonna do this more frequently. Just 2 hours and then I can do other stuff outside. Do you have any suggestions on how to solve this one? It has to be right on this level here. What do you mean? Why is this bad? So when both of them are on, it has to be off here. And if I do this, it's definitely not gonna work. So I have to make it so this doesn't turn it on, but then it's gonna fuck up the other tasks. Put another line on bottom and connect with what? The goal is to, you have these two inputs here, they're turned on, and the output has to be off, but it's currently on because of the other tasks that I have to pass. So this one works because this XOR gate has this truth table here, which is when both inputs are off, which are this two that it's receiving, is gonna be off. When this input is on, it's gonna be on, and then so on. And then this passes the first test, but then the issue is that it fails this one because it has to be off now. How old are you? Yeah, I had the sense you are younger, but it's good for you, man. Do you know how to code? Are you learning? So how am I gonna achieve this? Coding Roblox. Selling hacks. No man, don't do that. Gonna get in trouble. Yeah, too late. So if I put this one here, I don't think it's gonna change anything. The issue is I have to turn this off when this is on, which is a problem. Because if I do it like this, it's gonna... Maybe I need to change this gate here. Let's see if this passes the first. So now it's failing this one. So maybe I can do it like this. It fails this one now. So maybe I can achieve this by this. Yeah, now it works and fails on this. So when both of these are on, that should be off. So let me see if there are any other gates here that I can use. This one is not gonna work for the first one. This and the OR gate passes. NOR gate I don't think it passes as well. No, NOR gate, yeah, it doesn't pass because of the first. And both outputs are off, it's on. So I think I have to use either an OR gate or an XOR gate for the first challenges. Making hacks isn't illegal in kids game. Yeah, I'm not sure about that actually, but it's better not to. Like I don't really see the point, because then you lose the experience of the game itself. It's better to just play the game, unless you're doing it for some to help people, because yeah, I remember when I was used to play games when I was younger, and I hated people that cheated. Didn't make any sense to me. But maybe I don't know, because there were some games where it was kind of the standard to use other tools, let's say, and everybody used it, but it wasn't really. It depends on the type of game, I guess. I think some games it might be fine to just, because it's kind of like a thing from the game, but usually that's not the case. Yeah, it's like weak, right? It's weak mind. So the thing I'm having the most trouble so far is understanding how to make the output change depending on the input there. Well, if I use a NOT gate, I can't use the AND gate. which is uh, one line at the end. What do you mean by that? This line here? Or this is here, you say? Like this? This is not gonna. It doesn't work. The goal here is you have when you have these two inputs on top here, these two first ones, the output has to be off. This is what it looks like when the output is on. Now consider there's a current here passing through this one and achieving this and turning it on. Now it's passing through here and turning this on. But now when both of them are turned on, this is supposed to be off and it's on. So that's the challenge. So maybe the way that I'm doing everything is wrong and I have to restart from the beginning. But X way, do I mean this here, but doesn't change anything. It's not gonna change anything. I don't know if this is what you mean, but because it's not solving the issue. You have to think about one way that it turns it on when neither of them is on. When one of them is on and the other is off, it has to be on. But when only when both of them are on, it has to be off. So either one of them turned on, it turns it on. But when both of them are on, it has to turn off. So this gate here does that. You can see here. But if I use this one here in the beginning, it's gonna fail on the other test. So now it passes, but it fails on this one. Then if I put it here, it's gonna pass, but it's gonna fail on the other one. So it passes all of this, and then it fails here. That's why it's very difficult. To the end and two out. To the end here. Which one of them? Because the issue here is that if this is on, it's gonna turn it on. That's the problem. Because yeah, that's the thing. I'm using this to pass the first ones, but then every time this gate is on, this input is on, it's gonna turn the output on. And that's not what we want. That's why I don't think the XOR gate is the first one. Which one do you think I should use? There's all of these one available here. I'm not sure if you know how they work. You can see the truth table there. I can't put the mouse because it's gonna go away. To do things with PCs. Yeah, but it's good to understand how the computer works. Because then you can become better at doing things with the PC. If you understand how it's built. It is difficult, but I think it's worth it. So the 3R gate's not gonna be useful for the first one. Yeah. You should pat him every time before you go to sleep. What if I do this? It's gonna work. So I pass. It fails on this one. Where the output has should be on. Maybe why do you say sus? If I don't, I'm not really sure what sus means, but I think it's for when someone is acting gay or something like that. And people say sus, but I'm not really sure. It's relatively a new term that people are using. I don't understand why, but so how can I turn that? That should be on, but then it has to be off. So the third input has to turn it off when the first one turns it on. So I guess I can make an OR gate. Yeah, but the OR is gonna pass anyway. If either one of them, only if I could make the NOT gate. Well, but then I would need to use the NOT gate, which means I wouldn't be able to use the AND gate. Now let me try this. I don't think it's gonna work. Yeah, it's probably not gonna work because it's not gonna pass this once. I need something on the third one that is gonna reverse the output of the first one. Yeah. Oops. So the desired output is off, but this is on. So maybe if I connect this one to the XOR true, then it's gonna work. But then the OR gate is gonna give me problems. Well, this doesn't work. And the reason why I think is because this is going through here and then going through the OR gate, which is turning it on, but it's supposed to be off. If I've connected like this, is not gonna work. Yeah. So maybe like this. Now it fails on this one. Maybe if I connect an AND gate here. The issue is that the XOR is gonna activate every time one of them is on. Maybe if I change the gates here. Let's see. So when both of them are on, it fails. Maybe if I put here, let's see if this works. Oh, that should be off. That's the problem. That should be off when both of them are on. So select this. Yeah, but then it's gonna turn it on. And yeah, it should be off. And the only one that does that is the XOR gate. And if I connect like this, it doesn't make much sense. Because it's the same as connecting either one of them. Maybe if I, oops. Maybe if I do it like this. Doesn't work. So the question is, how can I make the third one deactivate the input of the first one? I feel like it can't be there on top. I think it has to be the XR on top. Otherwise it doesn't work. So I think that's the best approach at first. So connect the XR here. I just have to figure out how to pass this one. So maybe I use another gate. Maybe another XR gate. Connect it here. Yeah, but the issue is that it's gonna pass this one, but it's gonna fail on this one anyway. Because the desired output is off, but both of them are gonna turn on. What if I connect? Well, it's probably not gonna work, but I wanna see what the result is. If I connect an AND gate on this one, normal one, like this. should this one here. If I do it like this, it doesn't pass because it needs to turn it on. But I think that's the approach. This one needs to pass when one is on, but not when both of them are on. And the NAND gate achieves that, I guess. So let me see if this one works. Yeah, but now it fails on the first one. Huh. Because the NAND gate turns it on when one of them are on, which makes the XOR turn on. Hmm. But I think that's the correct line of thinking. Because I need something that uses the third input to turn the first one off. So it passes the other one. Maybe if I use AND instead. Yeah, but then I think it fails. Yeah, it fails on this one because the input is not directly connected. It has to be something that activates with only one, but deactivates with two. And I think the only thing that does that is the NOT gate. Uh, the NOT and the NAND gate. So this one doesn't work. I guess the XOR. Yeah, the XOR gate works as well. So maybe I can do it like this. Nice. Okay. There we go. Now is the problem. It passes this one. So it fails on this one. And on all three of them are off, it has to be on. And this one is on. So, okay, I think the first part is correct. Now I just have to figure out this one. So it's a matter of finding out which gate is gonna be the best to combine the other two entries. So it has to be off, but it's currently on. Hmm. So I need kind of like the same thing I did on here, but for the bottom, I guess. Because it's the same logic. But for this one and this one instead. But then it might screw up the other tests. Well, let's see. Oh, I can't. I can only use three. I forgot about that. Yeah, so that changes everything. Let's see like this. What happens? Yeah, now it doesn't work. So still failing on this one. So when both of these are on, it has to be off, but it's currently on. Oh, but the problem is also this has to turn this off. So what if I do, yeah, but if I erase this, it's gonna fail the previous task. Let's think Control Z, yeah, reverts. May do Control Z again. Yeah, so let me see if I turn this like this. Doesn't work. Yeah. Yeah, so this is gonna pass this one. It failed the other ones. So it needs to be off when both of them are on. But the issue is that the first one is gonna turn it on anyway. So maybe my whole logic is incorrect. Let's think about it. Maybe I can use another gate. Oh, clearly there needs to be a connection between the first and the third and the fourth one as well. So I feel like, yeah, it has to work somehow like this. Let's try this one. Nice. That's cool. Damn, that was hard. It was easier than I thought, to be honest. The XR was probably harder. But I wonder if it's gonna become a lot harder, which is gonna be very difficult then. Wire color, keep our circuit organized. Because we are so technologically advanced, we have machinists fold our socks. Partially the circuit that detects sock pairs broke on the machine. This level has four inputs. Output on when two or more of them are on. Don't overthink this level. Okay. output on when two or more of them. Oh. So pretty much the AND gate. Yeah, but it's gonna require more, I think, because of the combinations. But the logic, I think, is the AND gate logic. Yeah, but now it's off because these two are on and that should be on. So let me put another one here. So the middle ones are off. Oh, I can use the 3 AND gate or no? Yeah, this level doesn't have the 3 AND gate. But it has the R with 3. So maybe I should be using that. So inputs 2 and 3. It doesn't have a limit on inputs, so I guess I can do this. No, true. So I'm just gonna put an AND gate for every combination. It's probably gonna pass. But it's probably not the best way to do it, I guess. So hash should be on when 3 and 1 are on. Don't I have this combination here? Oh, guess not. Yeah, this is getting confusing. If it doesn't pass, it's gonna be hard to see which ones are giving me problems. There we go. Okay, easy. But let me think. Is there a better way to do that? The OR gate's probably not gonna work so well because it's gonna turn it on every time one of them is on. But I guess, yeah, I could use the OR gate somehow in a more complicated way where I turn it off with some other inputs. But I think I'm just gonna move forward. It says to not overthink, so. And I think I'm gonna do it laterally, even though I can do the other ones. I think I'm gonna do like as if it was levels. This level is my favorite pastime, converting decimal into binary under time pressure. Toggle the bits in the level panels to add up to the decimal number in the question. You must reach level 3 to pass. Click here to turn on timeless accessibility mode. So I should toggle the three bits in the level panel so that they add up to the decimal number in the question. Oh, this is gonna be difficult. I don't remember the binary as well. But I think what is 1 in binary? 1? True in binary. True. I'm not sure. I'm probably butchering this already. Yeah, I'm seeing like I'm doing as if it was decimal, but this is supposed to be binary. So I think this is too elevated to the. You made it level? True. I think this is too elevated to 1, but I'm not really sure. Now let me just do the normal calculation and see what happens. 12, 14. I think I'm not doing this the right way, but and this is really hard. If it really is in binary, then it's very difficult. Doesn't make any sense, though. If there is the way that I'm doing, I should make, yeah, done. 14, 18. $25, 22, 45. Damn. I'm just gonna do the. Okay. Oh, so I guess it's just this. So let's just do the math. It's kind of weird. I thought so. I'm gonna do then like this tree, then move forward. Only when I'm finished with the tree. I'm not sure if I did that level correctly, but apparently I passed. So I don't know. The last level, you unlocked the delay buffer. It outputs its own input. Just one tick late. Construct a circuit that outputs the same as the input, just delayed by 2 ticks. So this is gonna be by 1. I don't understand the explanation really well. I guess it's just this. Measure the universe with numbers, so your machine must learn to count. Treat the inputs as 0 or 1, depending if they are on or off. Add them together in binary, such that the result is either 0 or 1. As with normal addition, if the result cannot be described with 1 digit, set the carry to 1. So 0 plus 0 has to be 0. Don't know what this carry does. Maybe I'll read the level again. So 1 has to be on. Yeah, but then it's gonna mess up the other one. Oh, it doesn't. Yeah, so this works. Maybe if I go through here, it's probably gonna fail on the last one. Yeah. So when both of them are on, has to be off, so I can use an AND gate here, I guess. I'm already becoming better at thinking about what each gate does. Apparently not. Uh, so it's the other way around. Maybe it's the XOR that I want. Yeah, the XOR. Oh, so it has to be, well, desired sum, desired carry. So I think it's working, but I need to connect to this as well. Hmm. Yeah, because, well, one of them is on and the other is off. So it has to be one. Desired carry is 0. So it passes if I don't do this. And then the desired carry, this should be 1. This should be 0. No, it needs to be 1. So I can make an AND gate here. Like this. Yeah, but I'm not sure if this is gonna work. Let me read the level log again. Treat the inputs as 0 or 1, depending if they are on or off. Add them together in binary such that the result is either 0 or 1. As with normal addition, if the result cannot be described with one digit, set the carry to 1. Oh, because the digit is true here. Now I get it. 1 plus 1 equals 2, so it has to be 1 here. Mm. So maybe if I connect the AND gate directly here. I just don't understand how they are related. Yeah, there we go. It is one. The output component of this level is a binary counter where the first 3 pins correspond to 1, 2, and 4. Components needed 20. Damn, this is gonna be tough. 20 components. It's crazy. The output component of this level is a binary counter where the first 3 pins correspond to 1, 2, and 4. Use the binary counter to count the number of signals. Check this int if you get stuck. Tip: the solution for this level is not very neat and requires more components. So it means it's not so complicated. It just requires a bunch of components. I'm gonna need 20 components. So right off the bat, I think the AND gate passes, except this one. 3 AND gate. Oh, it fails this one. Desired output 1. I don't understand. Maybe they has to be connected to all of them. Oh, so it has to be on when this is on. That's why. So let me connect the OR gate. Then when 2 of them are on, it has to be off. Two of them are on, it has to be off. So let me do this. It already fails here. It makes me appreciate the people that did this in the beginning. It was probably even a lot harder because they didn't have these names and stuff. Just the wires itself. Which is crazy to think about. So how I'm gonna achieve this? That should be on, but when? So I think this is kind of similar to the previous one, but I don't remember really well how I did it. Oh yeah, I think I connected two XOR gates like this. Yeah, I had one here, then here, here, here. I'm not really sure if that's what I did. It has to be the first two ones. Oh, maybe I can just use the XOR gate. Yeah, but then it's gonna turn it on in the beginning. Because when they're all off, it needs to be off. Oh no, this works. So maybe just the XOR gate works here. In the first. Oh, it has to be on. Because it's true here. I keep confusing this input 4 with the output. So the output is true, which means it needs to be on. So it needs to be off, on, on. And both of them are on. Yeah, so if I put an OR gate here, architecture here, current output 3. Uh, so I don't understand why it's 3 there. And now it's 1. So it fails on this one because of the output. See something. This is gonna give me 1, but just wanna see if it messes up the other ones. Yeah. So maybe if I just use 2 AND gates. It says I need to use 20 components, so now it's giving me 3 and it should be 2. Wait a minute. Oh, now it passes. I think the other thing that I'm gonna do is change colors of the wires. Also, so I know which one is which. Now this is much better to visualize. And this needs to be here. Yeah, so now I need to connect something to the third, which is probably gonna be an OR gate. Because it has to activate. And it's gonna sum with the other one. So let me change the color again. Now it's giving me 2. So when I put on the same one, it activates the other. What? Why is this 4? Doesn't make any sense. Oh, I understand. So if I put here, it's probably gonna be 1. Yeah, that was correct. So this means 1, this means 2, and this means 4. Because it's the translation binary. Now I get it. So now it needs to be 2, but it's 1. So yeah, here it needs to be a 1. So I can't connect on either one of these. What if I connect this one here? Okay, so passes. So now it needs to be 2, but it's 1. So both of these inputs are on. It is giving me that. So maybe I need to put an AND gate here. That's the first thing that comes to my mind. Not sure if it's the best, but maybe it works. Oh, now it's screwing up the other one. So this can't be active. So I guess an OR gate is gonna work. I'm giving me 3 again. So this is the one that is failing. I need something that turns it on, but only sums 1, but doesn't screw up the other ones. Yeah, the AND gate should work. I don't understand why. Maybe I did it the wrong way there. Yeah, so here, connect this one here and this one here. Yeah, but then it activates. I don't understand how if the other ones are off. It's probably because the XR gate here. Yeah, this is just weird here. Like, even though this input is off, it's still going through to the XR gate. Oh, I guess it's because I have connected there. I think I forgot about that. Yeah, I connected before. Which color is this one? Is this? Great. This thing bugged. Hopefully it works now. Yeah. Might have to restart the game. Get bugged. Yeah, let's see what time it is. Still have a half an hour. The output component of this level is a binary counter. Use the binary counter to count the number of signals. I guess I didn't read this correctly. Or didn't understood when I read it. Okay, great. Now let's see if it works. Wish I could change the shape of the thing. Because then it overlaps. Maybe I can do it through of them. So I was just confused. Oh, and it isn't here. I didn't remember that I had connected the XR to the second one. That's why I wasn't understanding there. So now let's think. I have to output true, but is outputting one. I can just make another gate using the third one, but I think I already tried this and it didn't work. Yeah, now it's three. So maybe if I use the XR and connect to the other ones. But how is this? How does this have a current? Oh, because it's going through the XR and then it's getting into the third one. It's activating the third one. That's the issue. It's interesting that it is still passes to the XR when it was supposed to deactivate, but I guess because there is three inputs, it activates again instead of deactivating. So the first solution that I can think about is adding this. At least it passes the first one. So now it's supposed to be 2. So why is it giving me 1 if it is passing on both of them? Doesn't make much sense. Yeah, I'm not sure if it's going through this one. Probably not because it's returning here. Don't understand why can't I put this here? And then it's gonna fail the other tasks. That's the issue. And if I do it like this, it still doesn't work. I think it's because it has output from this XOR here. So both of them are turned on, which makes this don't activate. So what if let me change the color. What if I put it here, here? Yeah, but now it's more clear. It feels like it should be working. So maybe this one is the problem. So maybe if I put it here, it will work. Because then it's gonna be true. Yeah, but then fails the other one. It's outputting 3 because this is turning on. Let me change this to a NOR gate. It's probably not gonna work. Yeah. It can't be something that activates when both of them are off. Yeah, this one is difficult. The AND gate's not gonna work. Maybe we can use this 3 AND gate instead of the 2 one there. Yeah, maybe this one works. If I put it on the 3 here. So the challenge says that I'm gonna need 20 of this. So I probably need to nest them together somehow. Yeah, so now it's not working. What if I put a NOT gate here? So it turns it on. Then I'll have to put it on the top one. Still outputting 2. 1. So maybe if I do it like this, it's not gonna work. Problem is if the whole approach is incorrect. The difficult thing is that I also have to think about the binary numbers, how to sum them and get the correct value. Maybe this one will work. So when both are off, turns on. And when both are on, it turns on. It still turns it on. But because of all of them are off. Yeah, I think I'm gonna need to stack them somehow. If I'm gonna need 20. The question is how and what's the best way to go about it. Maybe I need to use more than one gate there for the instead of using XR for all of them. So where is this one coming from? That should be from here. So I don't understand why if I put something else there, it's not gonna work. Yeah, this gives me one also, but this is off. It's just representing the current that comes back here from this wire. Now I have this sum of 3. If I take this off, yeah, so now it doesn't sum there. Hmm. Yeah, it has to be the end, so it passes there. Maybe if I connect another end here, keep dragging the wrong one. Make it equal to 2. Also, when they are both on the same output, it doesn't sum them. That's good to know. I think it passes the one that it was failing. No, I was stuck on this one before as well. So what if I connect the R here again? No. That should be 1, so it's here. So I passed this one. But now the sum is 3. And it has to be 2. So it means that the third one has to deactivate the first one. If I can use the OR gate to connect to the XOR gate using the 1 and 3. Yeah, let me try that. It's probably not gonna work, but doesn't hurt to try. Because I think he's gonna fail then. The first one. Yeah, this one fails. Because I'm activating the second one. What if I change this to this? It still fails. Oh, that should be 1 and 0. So maybe this is not the best approach. So maybe I connected NAND gate here. I don't think this is gonna work, but I'm gonna try. I mean, it already fails the first task. Can't use this directly. I forgot. I keep forgetting this. Yeah, maybe I can use the NOT gate there. But it's the third one that is giving me problems. I think I tried this already, but yes, now it's 2. It's giving me 3. So how can I make the first one? I think I had this before, but I don't remember the solution. Oh yeah, I think I used the XOR gate there. It's probably gonna put the XOR here. That's the issue, there's no space here. Now I have to redo all the lines. I'm gonna redo this again. Oh, I don't know. I don't know if that's still correct. The way that I did it. So these are 2 and 3. Oh, now I don't. Now I don't know if that's the what I did before. So what I was gonna do is this. So it already fails on this one because there's no output on the 2. So maybe I did this one wrong. And it was here instead. Okay. So now it fails. I'm supposed to get 2, but I'm getting 1. So maybe if I do this here. Okay. Making progress at least. So now there's both in the middle. I can use an end here to activate the 2. Let me change the color. Oh, okay. Think I'm in the right direction at least. So now is the 4th input. So hash S should be 1. So I'm using 1, 2, 3, 4, 5, 6. And it says I'm supposed to use 20. It's a little bit concerning because it might mean that I have to change everything at the end. Which obviously is not gonna be good. Okay, so it passes. Now to the 4 and 3, I need to activate the 2. Which is a problem because I have to do basically the same logic that I did for the 1 and 3, but for the 1 and 4. So I think that's what I'm gonna do. I'm gonna repeat the logic above, but for 1 and 4. So I have an XOR here, connected to another XOR. So this connects to 1 and 4, which connects through here. And this is connected directly to 3. So maybe I'm gonna connect this to one and here. No, it doesn't work. Oh, so maybe the output is off. Yeah, but that's the issue because the one below, the one above is gonna affect. I need to stop this from working and so need to stop it from working and put the 2 there somehow. So this XOR, maybe I can connect this XOR to the 4 as well. This is a mess. Okay, now it works. Okay, it's making progress. It's good. So now it needs to be 2 and it's 1. So I need to deactivate again, which is tough. That's the issue. Current output is 1. Maybe the whole way I'm doing is wrong. Because here is not gonna sum if I put it. It's just gonna give me 1. And now it's failing on the previous ones. So I don't think that's correct approach. Maybe it does sum. It's only on this one that fails. I think the timer is up. I think I'm gonna leave this to another time. I think I can erase this stuff here. Because it's not making any difference. It's just this last 4 that it needs to pass. My concern is that if I change something, then it's gonna fail on the previous test, and then I'm gonna have to redo everything again. And I don't see a clear path to making this work. Unless I connect the XOR to the 4 again, but then I feel like it's gonna screw things up. Maybe it's worth trying before I go off today. It already fails on the first one. think there's too many connections to the previous. The issue is I need to get 2 and I'm getting 1, so this probably means I'm gonna have to redo the first. Which means I'm gonna have to redo all of them, so it is a problem. Is passing through the the third input. It doesn't work. Put an XOR here. Then it's gonna screw all the other challenges. Yeah. So I think I'm gonna leave this for another time. I might come back today and try to do this thing here. I'm studying the network library, so I'm probably gonna go through all of this while looking at the at Python. But I think I'm gonna do this off stream because it's better, so I can use the two monitors to do it. So if I don't come back, I'm probably gonna come back 2 days from now or even or tomorrow. So see ya.